Tablespace point-in-time recovery. We've covered point-in-time recovery a bit so far in the training, and I made a couple references to the fact that we can do PITR with tablespaces. That time has come, friends. By the end of this nugget, you'll understand exactly what tablespace point-in-time recovery means, what its use case is, and the types of questions on it that you can expect to see on your OCP certification exam. Of course, theory is just one half of the equation. You'll also understand how to perform automated TS-PITR. Boy, say that 5 times quickly, right? Let's get to work. So what is the need for tablespace point-in-time recovery? And you'll see me use this acronym TS-PITR a lot. It's in Oracle's own documentation, so you should be used to seeing it. Now, as I mentioned in the intro slide to this nugget, we're familiar with incomplete recovery, known as point-in-time recovery. To date, though, we've learned about PITR only in the context of restoring an entire database up to a particular point in time. I made the point back then when I taught you how to do point-in-time recovery for an Oracle database that what if you have need to reset only selected data files or a table space up to a particular time, not the rest of the database? Are we out of luck? Fortunately, we're not out of luck, and that's exactly what this TS-PITR does. So we know that we can restore table spaces completely, performing complete recovery. In this nugget, we're focused on restoring a table space and all of its associated data files to a particular time and date or system change number, or SCN. We remember that SCN denotes the time clicker or metronome, so to speak, for an Oracle database, and every single transaction will increment the SCN. And we can use the LogMiner tool found in Oracle Enterprise Manager to do that kind of analysis. We also have technology like Flashback Query, where we can determine what Oracle calls the target time. This is an important vocabulary term. When we deal with point-in-time recovery, we're always thinking in terms of what time do we need to rewind that table space back to. We're going to talk about in the next whiteboard the common use cases where we would need to use TS-PITR. The things to remember as far as definition is that TS-PITR allows us to recover one or more than one table space to a previous point in time, and that doing so will not affect other table spaces in the database. Now, yes, there are some gotchas, there's some caveats here to this. Perhaps the biggest one, as we'll learn as we go along, that your table space in question needs to be what's called self-contained. And what that means in a nutshell is that the table space and its accompanying data files don't have any dependencies, maybe parent-child relationships, perhaps indexes, etc., that span to another table space. You're not going to be able to proceed with TS-PITR unless and until you can ensure that your table space is fully self-contained. And perhaps the reason for this is just to cut down on complexity. After all, if we had table spaces X and Y and we only wanted to do TS-PITR on X, it would be difficult to do that while at the same time maintaining those relationships. We'd have to essentially bring back both of these to a particular point in time so that they would synchronize. This is really kind of an elegant issue, and it's asking a lot of Oracle to take just a particular table space and rewind it, whereas the rest of the database is far ahead of where that table space is, at least initially at the time of restore. So as we're going to learn, RMAN can automate TS-PITR. Thank heaven. I mean, you can do this manually if you want to, but RMAN automates the entire process. And in addition to doing the backup and restore processes, it will also take care of data dictionary metadata such that Oracle doesn't get confused in terms of having an old table space along with other table spaces that are much more up to date. Now, what are the major use cases? When would we be interested in using TS-PITR? Well, there's quite a few reasons, and many of them have to do with good old-fashioned human error. If you have an administrator or a user issue an erroneous truncate table where it clears all the rows of a table, you may not be able to get that data back using flashback tools. And of course, like I said, you don't necessarily want to roll the whole database back to a point in time. Tables sometimes become corrupted interrupted for a variety of reasons, that's another use case. Let me skip this next bullet point. We'll pick that up in just a moment. If a user or administrator's dropped a table with the purge option, that's going to bypass the recycle bin and put us in potentially a world of hurt if it weren't for the tablespace point-in-time recovery. And we could have erroneous data dictionary language, or DDL SQL, on tables that affect the table's structure, such that we wind up with a broken application, unhappy users, or both. All of those situations would be a case where we would be interested in restoring only that table space that contains those objects. Now you may be thinking, well, gee, that's still kind of hitting an ant with a bulldozer, right? I don't know if that metaphor works, but at any rate, because a table space is dollars to donuts going to contain more than one data file, right? And if we do a TSPITR, we're replacing all of the data files within that table space. And yes, that is in fact correct. So if we had a problem with a table that existed on only one data file, what are we going to do about the data that exists on the other data files when we rewind to a particular SCN or moment in time? Well, that is an issue actually, and it's a real issue, and it calls into mind other technologies like doing an export of that other data to make sure you've got it, do your TSPITR that resets the whole table space, and then doing an import to bring in the remaining changes. Again, it's not the cleanest solution. I have a feeling, this is just my educated guess, that TSPITR is going to undergo additional tweaks as we move along with subsequent versions of Oracle. Already, I think Oracle has it nailed pretty well, but there are issues like this that can cause us administrators some extra headaches. Now, I skipped this third bullet point because this bears special notice for our OCP exam. You'll find in a lot of Oracle literature that they will tell you that the TSPITR in 11G will not allow us to restore a dropped table space. We know we can recover from a dropped table, but dropped table space is no dice. Well, that has changed as of R2. A lot of this stuff is really heavily dependent, isn't it, upon the specific release, not just major version of Oracle, but specific release. In R2, Oracle folks, they've tweaked up the technologies that are used, I should say, in TSPITR. It uses now transportable table spaces and the data pump utility, so that as of R2 we can in fact recover from entire dropped table spaces. And like I told you earlier in this training, you always want to pay attention to new features, because generally speaking the vendor is pretty proud of those new features, and of course will include that coverage on the certification exam to ensure that the candidates at least know about those new features. We're a captive audience in some sense. The architecture behind table space point-in-time recovery is really quite ingenious and quite elegant. Like I mentioned earlier, you've got two options for actually implementing TSPITR. There's the automated method where we let our man orchestrate the process, and that is by far the preferred way to go and is in fact the exam objective that we're dealing with. If you do need more control over the process, you can override the automatic processing, but again, I would hesitate to do that unless you absolutely had to. Now let's look at what's going on. Remember, I mentioned that data pump and transportable table spaces are being used. So our man is actually doing a whole bunch of stuff. It's creating on the fly an auxiliary instance. If you've been watching these nuggets sequentially, you know what an auxiliary instance is. We covered that in the previous nugget. And in the previous nugget where we dealt with cloning databases, we had to actually install Oracle as a standalone instance to get that to work. Well, with TSPITR, what happens is our man brings up an auxiliary instance on the fly, keeps it up as long as the import and export happens, and then once you finish the TSPITR process, our man will decommission or bring down that auxiliary instance. It's just a temporary deal. Now, speaking of import and export, what else is going on? When you issue an automated TSPITR, our man is going to not only bring up that auxiliary instance in memory, but it's also going to export the control file from your your target instance. I guess I should step back and review the terminology. The target instance is your production database, and this contains the table space that you need to restore to a previous point in time. We also need to know the target time at which we need to or want to roll back that table space. All right, back to our regularly scheduled programming. The control file, as you know, is kind of the brains of the operation. The auxiliary instance needs to know where the data files are. It needs to understand system change numbers. You can, in fact, use the recovery catalog with the schema as well if you want to. The auxiliary instance is going to tap into two sets of data files. In Oracle terminology, they're called the recovery set and the auxiliary set. And the recovery set deals with the table space that's in question, not only the one that actually exists on the target instance, but also the copy that's in your backup repository. And of course, we do in fact have to have a good backup of that table space in order to do this to begin with. Now, in addition to accessing the raw data files, we need the metadata from the data dictionary on the target instance to be able to define the table space, the structure of the objects on those data files, all that good stuff. Of course, the table space does not exist in the file system. It's a logical object. If we don't have access to data dictionary metadata, there is no such thing as a table space, right? Now, the auxiliary set deals with system table spaces, really. This is how RMAN is able to dig into that data dictionary metadata. Here we're talking about the system, undo, and sysaux table spaces. Now, while all this is happening, while the control file comes over to the aux instance, while the aux instance taps into the recovery set and aux set, RMAN is also running stored procedures to see and verify that the table space under discussion is self-contained. Now, if it's not, if there are dependencies between objects in that table space and objects in another table space, then the process is going to abort and you need to resolve those problems. Assuming that the table space is in fact self-contained, we can proceed and RMAN will take the target table space offline for you. We'll restore the data files from the recovery set. Again, the restoration and the point in time stuff is all happening over here in that ad hoc auxiliary instance. The auxiliary database gets opened as a new incarnation with reset logs. And then now that we've got the table space and its data files brought back to the designated SCN or time date stamp, RMAN then works in reverse. It performs a restore or an export operation back to the target. All of this is automated for you. It's pretty cool. You'll see how it works in the upcoming demo. The only thing that you're responsible for as an administrator is at the end of the process to bring the table space back online. Let me show you the very simple RMAN commands behind this. Fully automated TS-PITRS. Actually, you've got 3 steps in the process. 1 optional step, set at the operating system level your NLS date format. This makes it easier to specify the time and date stamp used. Otherwise, you'd have to use the toDate function, which we've seen before in the training. It's certainly fine, it'll work. But at least if you do the NLS date format in your session, it's, 6 and 1/2 dozen in the other, whatever. In this case, we're going to use the NLS date format OS variable. Fire up RMAN, and this is the syntax to do a table space point in time recovery. We type recover table space, and then a comma separated list if we've got more than one table space to recover. Here's the money of the operation, until time, and then we specify as a string the date and time in 24-hour format. The specific formulation of this, again, ties back to your NLS date format on your system. And then we specify the destination. This is the staging area for our auxiliary instance. And that's just simply a file path, a Windows or a Linux file path. Once that process completes, we're going to fire up SQL Plus and bring the designated table space back online with alter table space online. Pretty straightforward stuff. To get a little more deeply into that basic process, specifically to determine the target time that you need, that would be the question, okay, we've had a failure, let's say at 3 o'clock p.m., how far back do we want to reset the table space? Do we want to reset it to 2:59? Do we actually want to give ourselves some wiggle room and go back further? How can you figure out what the best target time is? As a matter of fact, you may be able to use other flashback technologies and avoid TSPITR. Because TSPITR is going to restore the entire table space, that is pretty extreme, as we talked about before. Make use of things like flashback table. You may be able to reset just the table within the table space instead of the whole table space. And we're going to learn how to use the flashback table a little bit later yet in the training. We can use logminer if we're looking for a particular SCN value. We can use flashback query to query the table space objects to determine that time. So that's an important point. Secondly, the recovery set. I told you that an automated TSPITR, RMAN runs a stored procedure. Specifically, that stored procedure is called DBMS TTS transport set check. And what this does is looks for and verifies that the table space in question is self-contained. You as an administrator can query, you can actually run this as an administrator if you want to. Alternatively, we can tap into the data dictionary and query the TSPITR check view to do the same thing. Actually, if you're proactive, that would be smart to do before you initiate TSPITR. Third, and this is really important, we need to identify objects that will be lost after we complete the TSPITR process. Let's say we roll back the table space to 2:45. The error occurred at 3. The question is, what changed in that table space in that 15-minute window? Perhaps nothing that can't easily be redone. Perhaps there were some new objects. Maybe somebody calls you up and says, hey, I created a really important table, and you ask them when, and it turns out it was 2:51. What can we do about it? Well, after the fact, your choices are a little bit more limited. Maybe you have a clone database, maybe you have a standby database. Best to try to identify lost objects before we initiate TSPITR. And there's a system view called TSPITR objects to be dropped, and that will let us know proactively what's there. And the idea, the Oracle suggested workflow here, is to use Oracle export and import tools to snag those objects, export them out initially, run your TSPITR operation, resets the whole table space, and then import those objects back in. That's about as elegant as we can get with regard to that. All right, so without further ado, let's pop into the demo and see how this stuff actually works. In this demonstration, we'll work with Tablespace point-in-time recovery, also called TSPITR. Again, I can't get over how cumbersome that acronym is. Anyway, let's get this done. We're logged into OraNugget, which is my Windows Server 2008 R2 machine, on which I have a vanilla installation of Oracle Database Enterprise Edition 11G R2. Let me pop into SQL Plus as the DBA, as the sys user. One thing I didn't mention in the whiteboard portion that I want to make a reference to now is that TSPITR, in its basket load of gotchas, and yes, there are a number of gotchas with this technology, you want to make sure that you're not creating objects as the sys user, because the sys user, by definition, always has his or her activities tied back into the data dictionary. I hope you can see the potential problem. That is, if I go ahead and create a table space now and create some tables on that table space as sys, then I'm not going to be able to perform TSPITR because of those dependencies. Remember that the table space has to be fully self-contained. So what we're going to do is create a DBA user named Tim with a simple password of password, and then with that Tim user, we're going to create a table space and a table on which we'll perform table space point-in-time recovery. So a lot of what I'm doing right now is stuff that we covered in the DBA 1 course for CBT Nuggets. You should already have all this stuff under your belt. If not, make sure to go back and check out that training. We're going to create a user named Tim, identified by a password that I'm going to supply as password. Pretty easy there. And we're going to grant the DBA privilege to Tim. I'll now connect as the Tim user and verify that I am in fact logged on as Tim. We'll create a table space, pretty easy to remember, with the name of Tim, we need to specify the data file clause, and I'll just put that in my Oracle or a data folder as tim01.dbf with a size of 20 megs. I don't want the file to be particularly large. I'll now create a very simple table. Again, I want to remember this easily, so we're going to call this table T1, and I'll do a column 1 that uses number as its data type, and for C2, we'll use the date data type. And this is important. We need to specify the target table space. Because this is a vanilla installation of Oracle, if I don't specify tablespace Tim here, then this new table will be created using Tim's default table space, which is going to be users. That's not what we want in this case. We'll now insert into table 1 some values. We'll do row 1 with sysdate, and I'm going to wait a couple minutes and run this command again and add a second row so we can get discrete times. To let the cat out of the bag, what we're going to do is after we have 2 rows in table T1, we're going to grab a backup of that table space in RMAN, and we're going to perform a table space point in time restore after we delete the table. We can drop the table, truncate it, we can do it whatever we want with it. But in that TSPITR operation, we're actually going to restore to a time in between rows 1 and 2. So at the end of the process, at the end of the restore, we should have only the 1 row instead of the 2 rows. All right, I think enough time has passed. Let's do that second insert. And now let's select from that table, again, just in the name of verification. And I'm glad that we did that verification because as you note here, the way my date is set up, I'm not seeing the time, I'm seeing only the date, which is the 17th of April, 2012. Now that brings up the question, how can we change the date format? I mentioned that we set NLS date formats at the OS level. We could do some SQL magic using alter session, but I've found I get much more reliable results if we go out to the OS. We'll just have to be careful though, because setting the NLS date format is going to be a session-specific change. That is, after we kill this command window, that change will go away. The way around this is to set the NLS date format as a session variable, and we can do that from within SQL+. As you see here on my screen, I've issued alter session set NLS date format equal to the string using the specific pattern matching here. And you can check the Oracle documentation to learn how these patterns work. It's pretty intuitive. Although I'm not European, at least not directly, I like putting the date in front of the month, for instance. So I've done DD for double-digit day, double M for double-digit month, and of course Y is year, and I'm using 24-hour time going all the way out to seconds. Now you could switch this around to make it month/day/4-digit year. It's completely up to you on how you want to do that. We could, if we want to, also go out into the operating system by using exit. Well, I didn't want to do that. Darn it all. Let me come back into SQL+ as Tim, where I was before, if I can get my password correct. We wanted host, and then once we're out into the host operating system, we could do set NLS underscore date format equal. That would be export in Unix Linux environments. Of course, setting a session level variable, whether you're in the OS or in SQL+, you make sure you don't want to kill the command line window because that's going to hose up your format. Okay, so I want to pay particular attention to what's going on here. It looks like we don't have too big of a jump here between row 1 and row 2. Actually, it's a couple minutes, so I guess that'll do for our purposes. What I want to do now is snap a backup of this table space. So I'm going to actually exit out of SQL. Yes, I know I killed the session date format. That's okay. We'll come into RMAN, and first I'm going to grab just an entire database backup, and I'm going to tag this full underscore backup just so I know what's going on with it. After that, I'm going to back up just the table space. I just want to make sure I've got enough there in my backup repository. All right, that's cool. So now let's do a backup table space Tim, and I'm going to tag this as table space backup. Let this guy run out. And we can see here that we have one data file. It's file ID 6. It's stored in the location that you saw me use when I created that table space. And on this server, my flash recovery area is on my drive E, so we're getting backed up to a compressed Backup set, clearly you can tell that I have control file and SP file auto backup configured, and all that is well and good. Alright, now you might be wondering, well Tim, back when you were in SQL Plus, you didn't issue the commit statement at that time. Well, that's because, and this is again a DBA1 issue. Whoops, I need to connect as the owner of that object. Alright, so we'll run that select again. So that implicit commit does in fact mean that we have both rows recorded in the table. Now at this point, if we wanted to, we would be safe to drop the table if we wanted to. We could actually purge the table. We're going to learn about purge a little later in the training. This is going to bypass the recycle bin feature that Oracle gives us. I mean, normally we can drop a table and easily flash it back out of the recycle bin. Even purging would be fine in this case because we're about to do a tablespace point-in-time restore in between the times of row 1 and row 2. So let's run that query one more time so we can get those values, 2032 and 2034. So if we do a TSPITR to reset this table to where it was at 833, we should be okay in terms of we should only get back the first row and not the second one. So let's actually go ahead and finish this out. We'll go into RMAN again, establish our target connection, and the money of the process is the recover command. So we're going to recover the tablespace Tim until the time, and I'm going to choose the same format we've been using. 170412 20:33:0, and we're going to also specify the auxiliary destination. This is the staging area where the files are going to be restored. I have a folder on my E drive called Backup 1 that we've used before that I'll specify right now. And we get back an error message stack. We should not be afraid of seeing these. We should embrace them as learning opportunities. I think we can interpret this output by saying it must be my parallelism is set to 2 because we've got 2 channels spawned. That's absolutely true. And the error message stack tells us that the recover failed. Well, that's not particularly informative, but this last line is the Aura 1843 error, not a valid month. So yet again, we're running into NLS date format problems. I've got an excellent workaround for that I and many DBAs like to use, and that is issuing the toDate function. That will convert a string to a valid date format, and we can actually tell Oracle explicitly the format we want to use. So let me up arrow to bring back our commands. Recover tablespace Tim is going to be my first line until time. This is going to be where we're going to do some surgery, where we specify in double quotes toDate, and then I'm going to wrap this whole string in parentheses as the input to the toDate function. Make sure to close that with closing quotes, and inside the function we're going to specify our string. Let me get rid of this middle colon. That's going to be the first parameter, and the second parameter is going to be the model. So DDMMYY space HH24MISS, like that. Create a third line, and I'll bring back from my buffer my auxiliary destination statement. Alright, so here we go. We've spawned 2 channels. It's bringing back the auxiliary set. We have our recovery set and our auxiliary set, and check this out. Creating automatic instance with SID. This is a randomly generated string that RMAN uses because this instance is only coming up for the duration of this recovery. So let's take a look at some of the output as this thing cooks along. We see that Oracle is giving some initialization parameters for that auxiliary ad hoc instance, including a log archive dest1 and db create file dest as ebackup1. That's our auxiliary location. Oracle instance is started, and of course all of our SGA and processes and all that stuff happens. Then, as we discussed, we run our checks to make sure that the target table space is in fact standalone. You see that this is actually a scripted exercise. We have this what's called a memory script that sets the requested point in time. These octothorpes, or pound signs as they're called in more friendly language, are comments. So we're able to see what the heck's going on. That we restore the control file, we mount the database, we reset the archive log, and we just do a recovery, don't we? When that finishes completely, which it just did, we can now log in as that user, and we know what we're expected to see, aren't we? We'll verify that I am in fact logged on as Tim, and we'll select from T1. All right, cool. We have just the one row. So we've demonstrated Tablespace point-in-time recovery. Pretty elegant, although you definitely have to watch that NLS date format. That can certainly confuse you if you're not careful. Tablespace point-in-time recovery review. By this time, you understand what Tablespace point-in-time recovery is, and you understand not only the business use cases, but you understand the important proactive steps that we need to consider before we do this. This is a fairly dramatic recovery operation, albeit not as dramatic as setting the entire database back to a particular point in time. But as I've said several times as kind of a tease, we have a suite of technologies called the flashback tools in Oracle 11g that we'll learn about a little bit later in the training that can sometimes be a better fit for us instead of TSPITR. That having been said, if you determine that you do need to run this and use this, we know how to do TSPITR in the recommended or Oracle recommended fashion, the fully automated way. I hope that this has been informative for you, and I'd like to thank you for viewing.